Hey everybody, it is time to do some end behavior of graphs, and this is going to be for any kind of graph ever. Most of the time in math you talk about polynomials and rational functions when you care about end behavior, but this is just going to be for anything whatsoever. Like, for example, let's zoom. If I was to have a graph, it technically doesn't matter what happens in the middle when you're talking about end behavior. You only care about what's happening on the left and the right. Between these two sides on the left and the right, called the ends, is going to be something happening, and no one really cares what happens in the middle when you're talking about the end behavior. As you can see here, it is pointing down, and over here it is also pointing down. And that's really what the end behavior is all about. Which way is it pointing? It's pointing down, it's pointing down. And that's the end behavior. Now, the way you write it differs depending on what course you're in. The way we are going to be doing it is this way. As x approaches, then y is going to approach something. And since there's two ends, we're going to have to write this twice. So as x approaches something, y is going to approach something. And there's two ends, so I'm just going to kind of go like that. So over here, this is considered the left, because it's on the left. And on the x-axis, when you go left on the x-axis, you are going to negative infinity. So on the left side, this is considered negative infinity, and on the right side, this is going towards positive infinity. So this is just the fancy-smancy way of saying left and right. So on the left side, where x is negative infinity, it is going down, and down is going to negative infinity. Whereas on the other side, the right side, on the positive side of x, so positive infinity, it is also going down to negative infinity. Now, it is important to note that most of the time, this part's going to be pretty standard. As x goes to negative infinity, that means the left side. And as x goes to positive infinity, that means the right side. There are some graphs that don't do that. Like if I was just to make a logarithm graph or something, random like that, this doesn't go to the left. As you can see, it's completely blank over here. So graphs don't always go to negative infinity for the x, but most of the time they are going to. So I'm just going to be covering those in this video, just to give you a more realistic kind of graph. You could have something like this. Let's shove this down one more time. Boop. Make it more interesting. It's a polynomial, but when you're talking about end behavior, you'd once again start out with as x approaches negative infinity, which means the left side. What is happening? This arrow, it is pointing down. So you would say as x goes to negative infinity, the left side, it is going down to negative infinity as well. Whereas on this side, the positive side, it is going up. It's pointing up. So it would be positive infinity, like that. There are, however, some graphs that don't go up or down, they go over. So let's do something like, I don't know, that. Hello. If we were to do this as a graph, because I want to, I could do the end behavior of this graph. It is not a function, but who cares? It's fun. I could still do the whole. As x goes to the left side, negative infinity, is it going up or down? And in this case, this arrow is pointing down, so it would go to negative infinity. On the other side, where x is going to the right, this time it is not going up, nor is it going down. It is kind of going over. This one was clearly going down, but the other one's going over. And when it's going over, you have to put an actual number. Here, I didn't write any numbers down here, so I'm just going to approximate it and say it was -1. Boom, like that. So if it's going straight over at a number, you write the y value of that number. After all, it is saying y approaches. So make sure you're using the y value right there. And that's end behavior, just like that. I guess I'll put up some practice problems if you want to kind of guess and check yourself. I'll just make 3 quick ones. Things that can happen. Let's go with and something crazier like asymptotes for the win. Something like that. And lastly, something like that. So I would go ahead, pause it, see if you can kind of at least say, oh, it's going to be positive at negative infinity or whatever there. Or write it down, try it, just pause it, and then unpause it in 3 seconds. Okay, this one would be, well, I'll just do this part first. This is going up, this is going down. So this would be positive infinity, and this would be negative infinity. So the standard, as x goes to negative infinity or positive infinity, those will stay the same. This one goes up to infinity, this one goes down to negative infinity. Like that. Over here, as x goes to negative infinity or positive infinity. This one on the left is going up, and this one on the right is going down. It is important to know that, as I said on the previous side, all of this is garbage. You do not care. So yes, there were a bunch of stuff in this graph right here in the middle. This was going down, no one cares. This was going up, no one cares, because end behavior is all about the furthest left and the furthest right. So on the furthest left, it is going up, and on the furthest left, furthest right, goes to negative infinity. So this would be infinity and negative infinity. And finally, this one. This is going down, but this one is not going up or down, it's going over, so it's going to have to be a number. So over at, let's just let's pretend it's 3. Over at 3. So down is going to be negative infinity, and over at 3. So those will be the things we use. So as x approaches negative infinity, y approaches negative infinity, and as x approaches infinity, y approaches 3. Okay, that's all I'm going to talk about right now. Hope it helped. See ya.